Hey there, science explorers, ever heard of a rock that grabs metal? Boom! That's a real thing. Thousands of years ago, people found these amazing stones. They called them lodestones. These weren't just ordinary rocks, oh no. They possessed a secret, an invisible power, a force you couldn't see but could definitely feel. We call this incredible phenomenon magnetism. And guess what? It's working all around us all the time. Pretty neat, huh? Science is everywhere. So what exactly is this magnetism stuff? Well, consider this. It's one of the fundamental forces of nature. Just like gravity holds you to the Earth, magnetism has its own special pull, or push. It's all about moving electric charges. When tiny particles called electrons move, they can create a magnetic field. It's like an invisible bubble of influence. This force can reach out and affect other objects, especially objects made of certain metals. It's a force that's both mysterious and incredibly useful. Now let's talk about the ends of a magnet. Every magnet, big or small, has two special spots. We call these the poles. There's a north pole and a south pole. Think of them like the magnet's hands. One reaching out one way, the other reaching out the opposite way. You can't have a magnet with just one pole. Nope, they always come in pairs, a north and a south, working together. It's a fundamental rule of magnetism. Always two, never one. Here's where it gets really fun. Opposite poles attract. That means a north pole loves a south pole. They pull towards each other. Clicked, but like poles repel. Two north poles, they push each other away. Same for two south poles. Try it yourself with a couple of magnets. Feel that push? Feel that pull? That's magnetism in action. You're experimenting with a basic law of physics. Isn't that cool? Go on, give it a try. Let's zoom in, way in, down to the level of atoms. Atoms are made of even tinier things, including electrons. These electrons are always spinning, like tiny tops whizzing around. This spin makes each electron act like a super tiny magnet. A microscopic magnet, can you believe it? Each one has its own tiny north and south pole. It's these little guys that are the source of all the magnetic magic. So many tiny dancers creating a big effect. Now imagine a whole bunch of these tiny electron magnets. In some materials, these tiny magnets can line up. They all point in the same direction. When they do this, they form something called a magnetic domain. Think of it like a tiny neighborhood of aligned magnets. If enough of these domains line up inside a material, then bingo. The whole material becomes a magnet. A big magnet made of lots of tiny magnets all working together. Alignment is the secret. So magnets create an invisible area of influence around them. We call this a magnetic field. You can't see it with your eyes usually, but it's there. These fields are made of lines of force. They loop out from the north pole of a magnet, and they curve around to enter the south pole. Want to see them? Sprinkle some iron filings on a piece of paper. Then, put a magnet underneath. Wow, the filings will trace out the field lines. Science made visible. Not all materials are friends with magnets though. Materials like iron, nickel, and cobalt are ferromagnetic. That's a fancy word meaning they can be strongly magnetized, or they are strongly attracted to magnets. These materials have those domains we talked about. But what about wood, plastic, or glass? They are non-magnetic. Their tiny electron magnets aren't lined up. So, they mostly ignore other magnets. Different materials, different magnetic personalities, it's all about their atomic structure. Take a look at your refrigerator. See all those cool magnets holding up artwork, or maybe a shopping list. Those are magnets in action, every day. They stick because the fridge door is made of steel, a magnetic material. These simple magnets make our lives a little more organized and a lot more colorful. Such a simple invention, yet so incredibly useful. It's the invisible force doing its job right in your kitchen. What a marvel. But magnets do way more than just hold things. Think about music. The speakers in your stereo or headphones use magnets. An electromagnet, a magnet powered by electricity, and a permanent magnet work together. They make a diaphragm vibrate. These vibrations create sound waves. That's the music you hear. And electric motors? They're everywhere. In fans, blenders, even electric cars. They use magnets to turn electrical energy into motion. Powerful stuff from simple principles. Now, let's think big. Really big. Ever heard of maglev trains? Maglev stands for magnetic levitation. These trains don't have wheels touching the track. Instead, they float. Powerful magnets on the train and on the guideway repel each other. This lifts the train up. Other magnets push and pull it forward. With no friction from wheels, these trains can go super fast. We're talking hundreds of miles per hour. Science fiction? Nope. Real-world magnetic power. What if you have a magnet and it breaks? Oh no, did you destroy its power? Not at all. If you snap a bar magnet in half, something amazing happens. You don't get one piece that's just a north pole and one that's just a south pole. Instead, you get two brand new smaller magnets. Each new piece will have its own north and south pole. It's like magic. The magnetic domains just rearrange themselves. So, breaking a magnet just gives you more magnets. How cool is that? Did you know that our planet, Earth, is a giant magnet? Yes, it is. Deep inside the Earth, there's a core of molten iron. The movement of this hot liquid metal creates electric currents, and these currents generate a huge magnetic field. This field stretches far out into space. Our planet has its own north and south magnetic poles. They're not quite at the geographic poles, but they're close. It's like we live on a giant, spherical lodestone. This giant Earth magnet is super important for navigation. Have you ever used a compass? A compass has a small magnetic needle. This needle is free to spin, and it always tries to line up with Earth's magnetic field. That's why one end of the needle always points toward the Earth's magnetic north. For centuries, sailors and explorers have used compasses. They help them find their way across vast oceans and unknown lands, all thanks to our planet's invisible force. Earth's magnetic field does more than just point compasses north. It acts like a giant invisible shield. It's called the magnetosphere. This shield protects us from harmful stuff from the sun, like the solar wind, which is a stream of charged particles. The magnetosphere deflects most of these particles. Without it, Earth's atmosphere could be stripped away. So, thank you, Earth's magnetic field, for keeping us safe. It's a planetary superhero. So, as you can see, magnetism is a truly amazing force. It's invisible, yet it shapes our world in so many ways. From the tiniest electrons spinning in atoms, to the magnets on your fridge, to the giant magnetic field that protects our entire planet. Magnets help us make music, power machines, and explore the globe. The study of magnetism continues to unlock new technologies. It's a fundamental force that's full of wonder. Isn't science just incredible? Go explore,